Hello everyone. So today we are going to learn about the VPN. VPN stands for Virtual Private Network. So this is the most important topic of our firewall, and because the 40 to 50% of interview questions come from this topic. I should say the good interviews, right? Because there are a lot of cyber threats all around in the era of our work from home. So this is the most important topic, and every company is looking for this technology, so we have to be ready for that. Anyways, let's go ahead. So today basically this topic is going to be based on theory only. We will just learn basics of VPN, that what is VPN, and then in coming classes, maybe 2 or 3 classes, we have to be ready with the practicals, and we will do labs as well. We will configure VPN and remote access for that, right? So first thing that let's try to understand what is actually VPN. So you have gone through around in the name of like multiple VPNs like GRE or MPLS VPN or remote access, site to site VPN, IPsec. There are a lot of things you might have gone through, right? But let's try to understand that what is its requirement and why we need it actually. So let's just focus on that very simple scenario. Let's say there is one company here, means the company is same, but they are having the 2 offices, and there is one of the branch is here at the site A, and there is one more branch that is at site B. So obviously there will be some of the computers here, or some of the users here. Some of the servers may reside here, they will be working from here, and that server might be required to access by the users at site B, or there can be multiple servers at site B, right? And they used to be accessed at the by the users at site A. So these users need to access these servers. Obviously these will be accessing these servers, but that's not a challenge because they are in the same site. And the same thing, the challenge is going to be by accessing these servers. So this is going to be challenge. So the worst, not worst, in fact the first option by all the companies, which is very obvious, that they will connect these 2 offices via any of the circuit, right? They just lay a cable between both the sides, fiber connection, they take fiber connection, and obviously they connect it. But the cost of deploying this cable or this circuit or this optical fiber is very costly. Let us suppose this site A is in US, and let's say California, right? And another site B that is Singapore, or let's say in India, so that is in Delhi, right? So deploying of the optical fiber cable is quite costly, right? We cannot, our normal companies can't afford it. Even the companies which can afford it, if they invest a lot of money in the just deploying a fiber or connectivity, how they are going to invest in their business, how their business can grow, right? So this is really challenging, and this option is not feasible at all. The company do not prefer this option. What they prefer actually, they take the help of our internet. They take help of internet because internet is already everywhere deployed, and the internet companies have the connectivity of the optical fibers or the different MUX, and there are a lot of options available with the ISP, internet service provider. So what they do, they take the connections from internet, right? Let me change the color and check, make this little interesting, right? So what they do, they make take the connection from this internet, because this is our internet here, correct? So one of the circuit they take from here, they take internet and connection from here, and they take another connection from here, right? So that's how they connect it with both the sides. But as they are using the internet, but because internet is the bad guys there, they just do anything, they steal our information, right? Let me take big teeth as well. So that's how the internet world is there, right? Bad guys, so they can steal information, they can manipulate it, they can harm the companies or even individuals. So obviously internet is not a good place. So how their safe data will travel through an internet? So the solution is the VPN. Means that how that it is a public network. This is a public network, but we make it a virtually private. Virtually private. How we make it virtually private? That is the challenge. So first, there are a lot of virtually private options are available, and there was one of the challenge in the older technologies, or there was not a requirement of the ethical hackers. No, not ethical. In fact, the hackers were not there, and there are not of threats of the internet. Then what was the problem? The problem was, let us suppose here there was one of the company that is want to use one private IP address, and here also they are using another private IP addresses, right? Something like that one. And because these are the ISPs, so they might be serving to other companies as well, and these companies will be using these IP addresses in their network as well. So for that point of view, we also need to separate their user database. So for that purpose, we used to have the GRE, right? GRE stands for the generic route encapsulation. There what they used to do, we are having source and destination IP address. Like say this is source IP, this is the destination IP. Here that the source IP is 10 network, and the destination IP is this 192 network. So that is the private the enterprise data, and above that one, what this ISP are doing, they are adding additional header top of that one, because let's suppose they are having the public IP here, that's 100.100.100, right? And let's say this is the IP public IP address, we are having the 200.200.200. So there they will put as 100 as a source IP, and the destination IP as 200. So now this packet will be traveling, and this information inside of that one, that data plus the IP header of the enterprise will not be looked on while traveling to the ISP. They will be looking on to this additional headers, the source IP and destination IP, and that was traveling. But the main problem of the GRE was that this is not encrypted. That everything whatever is traveling, that is traveling on the plain text. Plain text means that if any of the hacker or the bad guy just sense your traffic, they can just read your data, manipulate your data, and then they can send it to other party or other site. So that was a little challenging. And another thing, same thing is done via MPLS VPN, and that is also totally dependent on the ISP, that because their traffic is normally if you are not putting in encryption from your end, the ISPs are not putting in encryption, so your data is also not secure. Although they separate the data from the different providers, but it's still the enterprise, but it's still their data is not safe, not encrypted, right? So the final solution, what it comes, that comes our VPN, IPsec VPN. So let's say that what are the different types of VPN we are having in because now the most important thing we are having here, there are three things. What the requirement is, the first requirement is our encryption. The data whatever is traveling should be encrypted, and even if anyone in between captures the data, they will not be able to decrypt it, so that data will be useless, right? The first requirement is our encryption. Second requirement is our hashing. Hashing means integrity, means that if anyone by mischance captures the data, they read the data, and if they try to manipulate it, right? Let's suppose this is our site A, this is site B, the data was traveling from here to there, and in someone in between, if that guy captures the data and they manipulate it, right? So let us suppose you have requested $200 here, right? And here this guy manipulated and that requested $500. They manipulated that data. So if they manipulated that data, then I should be aware that this data has been manipulated or this has been changed. So this is done via hashing or integrity. So first our job is that should not be captured or read by or manipulated by anyone, but by chance if it is read or manipulated by anyone, then I should be aware that it has been changed or manipulated, right? Next thing is our authentication, right? That to whom I am sharing that data, is that guy a genuine guy or not, correct? Because if you are sharing the information with the wrong guy, everything is ruined. You have encrypted the data, you checked that the data is not manipulated, but what if you do these two things with the wrong guy? You want to this A wants to do this, share that information with the B, but what if C is doing everything communication from between? So we have to make sure that we are sharing the information only with the B. So there should be some method that only it should be shared with the B only. So these three are the basic requirement of VPN, right? So in order to achieve these, what are the different types of VPNs we are having? Let me have a look on the slide here. I think I have it. And let's see that what is inside that one. So there are different types of VPN based on this requirement, right? So first thing is our site-to-site VPN. Yeah, this is better. So first requirement is our the first type of the VPN is our site-to-site VPN. Site-to-site VPN means that you are having one site here, and there you are establishing a secure tunnel between these two. So that is our site-to-site VPN. This is our site A, this is site B. So for that purpose you can set up put a firewall here, or sometimes we put the routers as well. The same features are also with the good end of the router, the good configuration of the routers, but obviously that is totally dependent that how much CPU intensive your router is it able to handle such type of encryption or hashing techniques. If it is able to handle it, we can set up the site-to-site VPN between even the firewall and the routers, or even firewall to firewall. So that is totally dependent if the feature is available on that device or not. So another type of access is our another type of VPN is our remote access. Remote access is like from one firewall there are multiple laptops are connected. That's now in trend right now. That is a work from home culture, right? Remote access, that everybody is having the remote access. You try to connect any of the gateway on the firewall and you just get a benefit or the features whatever you used to get inside the office. You take a real feel of your intranet, like you are connected to intranet. So that is a remote access VPN. But if you are taking the advantage of the remote access VPN, so there are two types of accessing that one. The first thing is like a full client, and another type of the VPN is SSL VPN. So whenever I talk about the full client means there is a one client software is being installed on your machine, then only you are able to connect to the firewall gateway. Means that then only you are having the remote access. That is the base concept of full client. So the example of these full clients are like you are using the Cisco ASA firewall, right? So in case of Cisco ASA, it is AnyConnect, or if you take the checkpoint firewall, it is having the endpoint, right? If you talk about the Fortinet firewall, it is a FortiClient. If you take about the Juniper firewall, that is a Pulse Secure, we use the client. And one more was there, Palo Alto, that was Global Protect. Global Protect is our software that we used for the, that software is being installed on the machine, and based on that software, your laptop is getting connected to the firewall gateway and you get the remote access. So that is the one way, means that whatever the way it is, if it is a full client, whatever the firewall it is, but the thing is that there should be a client, means that software must be installed in your machine, and that will be helping you to connect to the firewall or the gateway or the enterprise. Then only you get the remote access. Another type of the VPN is our SSL VPN. SSL VPN is totally based on the browser based, means that you might have seen some of the companies, they are still using it. They open a URL, they like HTTPS, and then whatever you are doing, you are doing inside of that browser window. Means that your entire computer is not connected to the intranet, means that you do not get all privileges what you used to get. You are having limited control, and you can just play inside the browser. Let's suppose you want to work on any of the tool that will pop up a new browser window, and you can just click here and there, and then only you can do the work. Like let's suppose if your Excel sheet you want to sync up with everything, that is not possible, right? Because your Excel sheet is residing on your machine, and your total machine is not entirely connected to your internet or your internet. So that's how it means that whenever you are using this SSL VPN, it is having the limited options. You do not get the full privilege or a benefit like you are just in office. So whenever you're using the full client, there are still two options of doing method of doing this one. One way is like IPsec. We can use an IPsec for that purpose, and another next way is like SSL. So SSL also you can use for the floor client basis. So it's just totally on mode of deployment, that how you deploy your full client remote access VPN. So these are the different types of VPN, how you connect it. So in all these features, whatever the types of VPN I am discussing here right now, they all provide the features of that encryption, hashing, and authentication. Means that whatever I'm talking about, they are totally secure, and nobody can manipulate the traffic. So let's go one by one. What are all these site to site remote access and all? So because today's session is totally based on the theory, so let's learn more that how they are and how actually they do it. Next slide is, I think, my site to site VPN. Yep, here it is. So in the site to site VPN, I think I have already told you much more, but for better understanding, this picture demonstrates well it here. This is one site, or you can say this is a local site and this is a remote site. And if any of the connectivity or the between from the local site to remote site has to be made, we take the help of our internet. That's how we are going it here. From this checkpoint firewall, this is just one example. It can be any of the firewall, like Cisco, SA, Fortinet, but we are learning checkpoint, so I have just taken a checkpoint. But you can take any of the firewall. The concept remains same. There is no change in that one. So that's why here, because I have taken this image from the internet, but that was quite good that they have taken the checkpoint here and Cisco router here, right? So even they are having the different vendors, but still we can form the VPN tunnel between them. based on the security parameters, that which of the encryption method you are using, what of the hashing technologies you are using, hashing method you are using, and what are the other PSK pre-shared keys we are using. So based on these requirements, we can set up our site-to-site VPN, and that will be established over the internet, and we will be having the totally secret communication over the internet. So that's how this is virtual private network. We are sharing the public network, public infrastructure, but still our communication is safe and secure. Perfect. So that's how it is. Next type of our VPN is remote access VPN, right? That's what we are much interested, because site-to-site VPN is also used, but why we are not interested too much, because we do not feel it. But yeah, this is very much important for the enterprise. Whenever we are having one office in Delhi and another office in Pune or in Bangalore, or it can be in Chennai, right? There are different locations. When you are having the different locations and you are using the internet service provider, then this is the way we do it. Next thing is our remote access VPN. So this is just in image. I'm not sure you or this is visible clearly or not. Let me zoom it. Yeah, so I think this is actually I have just downloaded this image from the internet, so this is little blur, but still it was explaining well, so I thought to take it. So this is like SSL VPN. This is a good example, right? So we are having one firewall here, and from this firewall we are having the remote user, right? You see that remote user with any browser means that user will be opening any of the browser window here, and then it will be accessing whatever the URL has been provided by the enterprise, and they will access it, right? So based on this SSL negotiation, they will just set up it, right? And they will be able to open establish a secure tunnel between the remote user and the firewall, right? So that's how it is actually. And this is not features, all the features not available inside the laptop. You cannot use all the features. It's like if you are pressing the Windows key or something, right? So it's not working. No, it will be working, but you do not get that things connected to your internet. So that's how the difference is. Whatever you will be doing, you will be doing on the browser. I think you guys might have idea that I don't know you have worked or not, but I remember in one of the Citrix tool I used to work, and there they used to we used to open one URL, something like that one. It was having multiple icons inside that Citrix URL, and once I click that tool or whatever I want to open it, that can also be like a browser or something, it can be. Then it is pop-up another browser window, and whatever will be happening that will be inside that browser, whatever you want to do. So that's how it means that now if you suppose you click it here, something you link, again it will pop up a new browser window. And let us suppose even if there is an Excel sheet, so that will also be inside that browser only. It will not allow you to open that Excel sheet in your machine. Or even if it is a PowerPoint, for that PowerPoint also it will give you a window, browser window, and inside that browser window you will do whatever you want to do. Even if you open the remote desktop, right? Sometimes we use that RDP. So that even that for that RDP, you just click it, it pops up a new browser window here, and inside that browser window you will be having like a remote desktop. Then you will enter credentials and it will be working. So it is not taking the benefit of your machine. Your machine is not connected. Whatever you are doing, you are just totally from one browser window to another browser window. That's how it is happening. While if we are using the full client and IPsec client in your machine setups a virtual adapter. It's like let us suppose your machine gets an IP address of 192.168.1.3, right? You connected via your local router, so you get that private IP. You click that local client, you connected. Let us suppose you take as a any of the client, like suppose 40 client, you take it, right? Let's you take it 40 client, and you just set up put the values, username, password. Sometimes they put the third one-time password or something others as well. So you put all these values, you click hit enter, and you obviously it will be having some gateway URL or gateway IP address. And once you hit connect, automatically it starts setting up a VPN adapter. Obviously your Wi-Fi adapter will be having this IP address. Now once you set up it, this 40 client or any of the client which is available in your machine, it will create another adapter. So this adapter will be working with this IP address, and it will be taking an IP address from your intranet service provider. So let us suppose they are using an IP address of 10.100.10.1.1, right? Just a minute, guys. So that's how it is. And now whatever the communication will be happening, that will be done from this IP address. So even if your gateway is residing in US, your machine will be treated getting an IP address from the US. Even if you see the location of your machine in the Google, and then it will be showing your location somewhere in US, because you are communicating through IP address which has been provided from your enterprise or from your company. You are not using the IP address which is being provided by your local service provider or local internet service provider. So that's how the benefit of VPN. And even right now, if you observe, there are a lot of private VPN providers. Some bad guys use that. Not bad guys, in fact, if you want to make your location safe, or you don't want to reveal your location or the where you are or who you are, you can pay any of the VPN service provider. What they do, they give you a VPN. You pay for that. They give you a VPN access, and let us suppose you buy a VPN from Singapore, and you are in US, and now whatever you take the service of VPN, your machine will be treated as like you are in Singapore, while you are in US. You can do whatever you want. Anyone want to trace you, they will think that you are in Singapore, while you will be doing anything sitting in US, and whoever want to trace you, they will think that you are in Singapore. So that's how it is happening in VPN. I think that's okay. That's more information. There's never ending. You keep on speaking, keep on learning. There's no way to end that one. I will keep telling you more information as the time comes, because if I tell everything right now, you will not be able to understand most of the things. So this is the first method, first way, what I was telling you. We discussed the three things: encryption, hashing, and authentication. So the first way is our encryption. So that's what I'm going to discuss it right now. So what is actually encryption, right? Our focus is what is encryption, right? So the thing is let us suppose you are sitting here. This is you, that is okay, let me say I and this is you, this is server, so let it be server. This is I, and I want to communicate to this server. What I did, I typed it hello, I use some key, right? Hello plus key, we used some of the algorithm, and now using this algorithm, this hello is being converted to any of the random bits. This is called as ciphertext. Means that was the original information, that was a hello, but using your key, you have encrypted that information like this ciphertext, and now it is traveling like this. If anyone captures in between, they are not able to decrypt it without the key. If they have the key, they can decrypt it, and if they don't have, even if the server don't have that key, they will not able to decrypt it. So that's how the benefit of encryption. Your information is traveling in a secure way throughout the internet, right? This is the internet, so that's how we do it. We put information, our information is converted to the some encrypted information, and then it is traveling to the server, right? So doing this one, there is a two algorithm. So one of the algorithm is symmetric algorithm, like this is symmetric, right? And another algorithm is asymmetric algorithm, right? So what is the difference between these symmetric and asymmetric? And another thing is that when we use these, when we use symmetric algorithm and when we use asymmetric algorithm, right? So one way, right, this what I just said, that let me change one color. Oh, this is not good one, this is better. So one way, what I just said, that was the information, that is hello here. We used one key here, right? There is a one key, right? Let's suppose key 1. Key 1 was used to encrypt that data, and the same key here, key 1, will be used to decrypt that data. Means that to encrypt and to decrypt, we are using the same key, right? The same key will be shared, means that here it will be having that key, and other side as well we will be having the same key. And this type of communication or this type of algorithm or the encryption method we use is at a symmetric algorithm, where for the encryption and decryption we are having the same key, right? We also call it as a shared secret key. This is a very important term here, shared secret key. Key is secret, but still we have to share it, because if you do not share it, obviously the other party will not be able to decrypt our data. So that is the very important part here. But the challenge is here that what if your you want to share your secret key, right? The challenge is to share the secret key, because if your tunnel is not established yet, right? So it means that your encryption has not started yet. If your encryption has not started and you want to share that secret key, obviously that will be going in the plain text, and that is a huge loophole in your technology. Even if what happens that if a wrong guy captures your secret key, he will be able to decrypt all your data, whatever you are just putting all your effort for encryption and decryption, then all useless, Any wrong guy can be capturing and decrypting all your data. He will be listening all information. Even he can manipulate that data and encrypt it again and send it to the receiver. And receiver will still be listening that it is coming from the genuine source. So that is a really big challenge, right? So the solution of that one is our asymmetric key. Solution of this thing is our asymmetric key. Let's see that what actually is asymmetric key and how does it solve this problem. First we will see the concept, that what it is, then we'll see that how it solves our problem. Yeah, here it is. So this is the one way what I just explained, the symmetric algorithm. So the example of our symmetric algorithm are the DES, 3DES, AES and RS4. These are highly used symmetric algorithm, algorithm. But the thing is here, the shared secret key. I think I have explained you a slide before what I have to explaining here, right? I explained you the things slide before. I think I missed the slide that I'm having this. Not a problem. So the key length here can be hundreds of bits, means that whatever the shared secret key we are talking about, that can be of hundreds of bits long. So this is efficient, fast and suitable for bulk encryption. So there's nothing more what I have just explained. That's the same thing here, but the main focus point is our asymmetric algorithm, right? So let's just focus on that, and then we will learn both of them when we use the symmetric and when we use asymmetric. Just bear with me. Why I'm just going you step by step so that you do not get confused and you grasp all the things. If I tell you everything just now, you will be confused, and most of the teachers just do it, and I don't want to do by me and you just get confused and crying here and there, right? So this is our asymmetric algorithm, right? So in asymmetric algorithm there will be two secret keys, right? One of the secret key is called as the private key, another one is called as the public key. Every site, let us suppose this site will be having its private key plus public key. Okay, so the site A will be having let us suppose this site, this is site A and this is site B, another site. So or left or right, so we can say the left side is having the private key and public key, and the same way our right side, that will also be having the private key and public key. Private key and public key. What happens actually that while starting the communication, the public key will be shared with each other, means that public key from the right side will be traveling to this side, this public key comes here, and here public key of left side be traveling to this side. So the pink one or the red one goes to right side, and the blue key or the public key of this side, that comes to left side. So the public keys are now exchanged. So whatever the diagram you are seeing here, that is actually after being shared, means the public key has been shared, right? Our public key has been shared. They have exchanged the public keys. So in this asymmetric algorithm, always the public key is shared and the private key always remains with each other. Private key is never shared. So this is the key concept. Now what happens that with this public key of the other side, means that this public key, whatever the received, and the private key of its own, plus there are some random bits, we take it and then this generates a key on here the left hand side. Same thing is done at the other side. We are having the private key plus public key, right? Private key of its own, public key what has just been received, and plus some of the random bits, and the key generated is known as the Diffie-Hellman key. And the concept and the magic of this Diffie-Hellman algorithm is that the key generated with this mechanism is same as other side. So the Diffie-Hellman key generated this side and the Diffie-Hellman key generated on this side, both will be the same. You see, they have, the key has been generated by their devices by themselves, by just sharing the public keys. The private key is never being shared, but still they have generated the key which is identical on each of the side. Here also, let us suppose they have generated the key as ABC, and here also they will be generating the key as ABC. They are having the same key, and using this key they will be encrypting that information, encrypting and decrypting. So ultimately we never shared the private key, but still we get the DH key in order to encrypt our data. So this is the magic of our asymmetric algorithm. So what the challenge we were facing in the symmetric algorithm, the challenge was sharing the shared secret key, right? The challenge was sharing the shared secret key. That is not problem in asymmetric algorithm anymore, right? But this combination, although this is a magic and this is very much helpful, we never shared our private key and still the key is automatically generated on both the sides, and that key is identical. We can use that key for encrypting and decrypting, and our communication will be secured and encrypted. But the problem is that this is very much process intensive. Process intensive means it takes a lot of CPU and RAM uses. It takes a lot of RAM processes, right? Our normal machines, the devices are not able to handle this, much lengthy complex algorithm. That's not possible at all. So what we do in our environment, we used to take help of these algorithm, right? We take the help of asymmetric algorithm plus the symmetric algorithm. How we do it? Let's see. We take the help of asymmetric algorithm. We take the help of asymmetric algorithm in order to share the shared secret key here. Means the first communication, whenever our tunnel is being established, we will be using this method, that our Diffie-Hellman key, right? Because here we don't have to share the secret key, or we do not share anything, right? So our encryption is set up like we form a tunnel here using the method of the asymmetric algorithm. Okay, and once this method is set up, we will share our shared secret key, because now our tunnel is established and our communication is safe. Then with using this method, we will use this share our shared secret key, and now everything will be happening using this method, because this method is very simple and it is not taking high RAM and CPU. No, not high RAM and CPU, right? It's not taking very much high RAM and CPU. So what actually we are doing, whenever we are establishing the connection, remote site VPN, the first we will set up this method, we will form a tunnel, then we will move to this method, we will share the shared secret key. We have both the sides, we are having the key, and our encryption will be keep on going using this symmetric algorithm method, and that will also not take a lot of CPU and RAM uses. Correct, guys? This is quite complex, I understand, I feel it. If you do not feel confident, you can watch through once again, but I highly recommend to not to refer any of the other things, because that really gets you confused. But still you are confident enough and you think that you can handle such of things, you can refer some of the topics. But really, I'm just really telling you, nobody explains in such a way, in the so much detail. The first thing, that nobody explains you in such a detail because they do not explain you, so you don't have to worry. You just learn phase 1 and phase 2 tunnel, and you just mug up the things and you go ahead, right? So these are the basic cryptography fundamentals, and we basically learn in cyber security, but we have to do it, so I'm telling you, right? So this is the method of encryption. We use it here. This is our encryption, right? Another method or the requirement was the hashing or the integrity. So let's see what it actually does. The message integrity is basically like you are having some of the message, right? And it is going through some of the hash functions, and it is generating some of the digest of that information, right? So this is basically like message integrity or hash functions. So examples of this are MD5, SHA-1, SHA-256, SHA-384, and SHA-512. What happens actually whenever you are having any of the message, right? Let's say very simple, hello, our favorite message. Let us suppose this is our hello method, and this message has to be traveled through our internet. What we are going to do, we will pass this hello using this hash function through this funnel, and we get some digest, right? We get some of the information. So we will send this hello along with this message digest, whatever we just got it here. Along with this will be traveling through our internet, right? It will be traveling. It has been received from the on the other side. Now what other side will do? Otherwise, other side will put that message aside. It will not touch that message. It will take that digest, whatever that digest was there, right? Not put that message aside. It will put that digest aside, and it will take that hello message and pass through the same hash function here, right? So if that pass through that hash function again, it should get the same output what it has been received. If this is ABCD, then and we have received ABCD, it means that our message has not been changed, it has not been altered, or it has not been manipulated. But what if that the received digest is ABCD, and here there is you are, whenever you passed this hello message, you got the digest at ABCF, right? So it means that our message has been manipulated, or it has been changed. In that case, we will ignore that message or drop that message, and we will request site to send that once again. And if it is happening again and again, then obviously we will have to check the loophole in our network that someone is listening our messages. We are having the different cybersecurity features that we can just check that where the loophole is there and who is just altering our communication. So that's that's a totally different topic there. But the thing is here, that is a important thing, that is that we have to make sure that our message is not changed. We are having the message integrity. Some of the times it is also known as the authentication. In some of the devices is written as the authentication. This one authentication means that they want to say that this whatever we are receiving that is authenticated, means that is the correct one. It's whatever we are receiving, that is the right thing we are receiving. So that is means that's what they are referring by this word authentication some of the times. One of the more complex method of doing this one is like whenever we are putting this message through hash function, we can also use a key here. The same thing, we are using the message integrity, but while passing through the hash function, we are using one key here. And whenever we are doing that one, that is known as the HMAC. Message plus key makes it more secure, because now you have to guess the, if anyone wants to do it, they have to guess that key as well. They have to be aware of that key as well. Some of this times is known as salting as well, right? So this is more secure. This is the total difference between the HMAC and the normal hash. This is known as the hash, whatever we do it, and if we use the key here, then it becomes an HMAC. That's it. This is the only difference between that one. Now the third thing and the important thing was what I was talking about, the authentication, that we have to make sure that whether we have taken the example of our, that we are doing the things, that we are doing the encryption, integrity and everything at all, but we have to make sure that whether we are sharing the information with the right guy or not. So that is the challenge. So in order to do that thing, we have to make sure that we are sharing the information with the right guy. How we are going to do it? So obviously that is the very common way of doing that one, and we used to do that, which is our authentication, right? You have to put authentication between site A and site B. This is site A and this is site B, the highly required thing, right? We used our private key and public key, and our public key was never shared, right? Here also we were having the public and public. What if, right? It can be that if your public key is shared with the wrong guy, because there can be another guy as well, right, with the private key and public key. And what happens that if you exchange that your public key, and that guy exchange your public key, you generate a Diffie-Hellman key. You should be doing that one with this guy, but you are doing with the totally wrong guy. What happens now? There is a no control on that one. You never shared your private key, but still you are negotiating with the wrong guy. So for that purpose, we use the authentication, that is known as the PSK. PSK means pre-shared key. That is totally pink now, huh? Interesting, but looks good. That is the pre-shared key. Pre-shared key means that we will set up some password here. We'll set up some password. That password will never be shared. That is just configured here, and we will be able to communicate with this guy only. Now obviously if there is an unknown user, he will not be knowing my password. So that is mean by PSK. So obviously we'll be using some PSK method for that one, right? So there are three things. First thing, we will use our encryption, right? So for the encryption, we can use our shared secret key or the DH key, Diffie-Hellman. symmetric or asymmetric algorithm. Another one is like hashing or the integrity, and another third thing is our PSK, pre-shared key. So that's what we are going to do or configure in the real devices, and the combination of these three are going to be either IPsec. So that's what we are going to learn in the coming session, because this is already a quite long session what I have covered till now. I have told you a lot more information what is normally not being taught, but still I think that was really required in order to understand that one, and configure, not required in configuration. Even if you don't know these things, you can configure it, yeah, but you don't know, if you don't know the background, that does not give you the real feel of that what actually you are doing. So that's why it's very good to learn that what actually you are doing. Although this is also not a limit, you can go inside that symmetric and asymmetric algorithm, how the keys are generated, how the algorithms are calculated. So there is never a limit, but still I think we should be setting up some limit, otherwise we will be going to an R&D engineer, research and development, not the normal firewall engineer, right? So obviously we have to stop somewhere, or we have to put our limits, that how much we have to learn in this phase, and where we are doing the PhD, then how much we have to learn. So we are not going doing PhD, we are just normal engineers, so we have to be with that only. So that is sufficient, I think. In the next session I will talk more about the IPsec, that what actually the IPsec is, and then we will, if the time permits, then I will take the lab as well in the next session. Otherwise I will take the lab on the later on. Okay guys, till that, bye bye, see you soon in the next session.